I would like to welcome Jongboom from Amsterdam. Please.
Yes! Thanks, Irina. Irina has been the greatest host on conferences so far. I mean, can we just give her hands one more time for organizing this whole day? Yes. All right. Now there's one little thing that I was kind of disappointed by, and that was this title slide. Like, come on, look at this. This is not a good title slide for a talk that is called "Fun with JavaScript and Sensors." This is how that should look like. You know, balloons and big text. So disregard previous slide. This is my slide. Hi. Fun with JavaScript and Sensors today. My name is Jongboom. I'm a software developer. Well, software developer doesn't really cut it. I'm a developer. That's it. I used to do a lot of software. I've been working with Mozilla for the past 2.5 years, working on Firefox OS, Mozilla's mobile operating system. And I've done that from Telenor. It's a telephony company, a bit like Live here in Ukraine. And they pay me from their R&D budget to work on Mozilla projects. So for the first 2 years working on Firefox OS, and for the past half year I've been working on exploring the Internet of Things space, seeing what we can do with hardware. And based on that, I've done a bunch of crazy experiments, and I'm going to give you the quick summary in the next 40 minutes. Now, besides doing actual development, I have to do quite some evangelism, and we're gonna do a little Where's Waldo game here, because this was me at a talk in Bangladesh, and I wonder if you can spot me. Alright, so enough about me. Let's talk about you all guys here in the audience. We're at a conference called JavaScript Frameworks. If we would think about this 10 years ago, would have never imagined that. JavaScript Frameworks Day? Really? No one likes JavaScript. Why the hell would you go to a full day conference? I have been exactly like this. This is Little Young. Yeah? I was 10 years old, I think. And I was pretty straightforward. This is what I said. And I know that you guys have all been here too. And every time I say this, I'm a little bit embarrassed, but actually the first web application that I made, I despised JavaScript so much that I did it with VBScript. You know, this is something that I've seen everyone go through. A complete despise of JavaScript. But I mean, it was justified. It really was. I mean, for the first 15 years of JavaScript existence, it was a freaking laughing stock at school. Rightfully so, you know, all the goodness that we have today with ECMAScript 5, and now with upcoming ECMAScript 6, ECMAScript 7, you know, where we transform JavaScript from, you know, a little scripting language to make your title bar blink in Internet Explorer 4 into a fully fledged programming language that you can build real applications with. You know? And no one saw this coming. And now all these people, Java, C#, Perl, that have been laughing at us for years. Not anymore. So yes, we're the king of the world now, and that's why I'm so happy to see all of you here today, at a real conference that had JavaScript in it. If you think back about the days that JavaScript started, or that the web in general started, computers were completely different than at this point. We're basically before the whole mobile revolution. Our input methods were incredibly limited. Basically you had a keyboard and a mouse as input and a screen as output, and that's it. If something that you would do today, at all the time in your application, vibration of a phone,
That was like 10 years ago, that was like super weird. Like vibrating your computer was like something you had to go on the internet and complain to others about. And JavaScript was never really made for that kind of interaction. You know, we're really behind this whole thing. Like a vibration API added to web browsers, that has only come 2.5 years ago. So really, we have to like catch up, you know? For example, throwing your computer down on the ground is impossible to detect without an accelerometer. You know, 4 years ago, with your native application, you could detect this. With your JavaScript application, not so much. We're closing the gap. Slowly. We need to, because sensors are freaking
important. Just look at like the whole list of sensors being added to mobile phones. A proximity accelerometer, ambient light, magnetometer, gyroscope, a pressure sensor. Even the battery of your mobile phone has sensors in it. If you look at like the copper platings to connect to your main board, only the 2 outer lanes are for power. The rest are data channels, just to let the battery like tell you like, oh, this much percent is full. Pretty cool. It's a trick that you can try yourself. If you use a little anti-static tape to tape off the data points that leads to outer lanes open, your phone will always tell you that it's almost dead. Because then you shut off the sensor. If I look at this whole list of sensors, it's just sensors in the Galaxy S5 and the new iPhone. There's only one sensor that actually is, and that's the bad sensor. So, we have a whole bunch of sensors in mobile phones. We're slowly getting there also, like using this for JavaScript. And then we see look, the new movement arrive. And that is the Internet of Things movement. You know, the fact that at the moment you can buy an Arduino or you can buy a Raspberry Pi and just plug and play like one of these sensors in and build your own connected project. It's freaking amazing. One, it's amazing because of the price. Like 10 years ago, you would never think you could buy an accelerometer, something you can actually detect motion for a few bucks. Like under $1 if you buy it directly from the factory. And the only reason for that is because mobile phones have been a commodity. They've been pumping out 1 billion accelerometers a year, and it drives price down like crazy. And for me, when starting to play with the Internet of Things, this is by far the most important. That I can connect the Raspberry Pi to my television, I don't really care. That I can attach a sensor to the Raspberry Pi and read real-life data, like temperature, for example, and then use that information to do other stuff. I don't know, let's say that you have a watering system in your garden. With software write programs that actually interact with the real life. How freaking amazing is that? That's cool. And even on like a mobile phone level, constrained to the little box standing on your desk, you can now write programs that actually interact with the real life. How freaking amazing is that? That's cool. And even on like a mobile phone level, you see this. Like look at these applications that have come out in the past years. They use like mobile phone sensors, mobile phone APIs in a unique way. Moves, now acquired by Facebook, just sits in your pocket, runs on your phone, just automatically detects where you're walking, where you're running, where you're cycling, etc. It gives you like a nice idea. It doesn't really have a user interface. For the most part of the day, it just runs and gets sensor data. No longer like clicking with your mouse, like, oh, I ran for 10 minutes. No, it automatically detects. Instant heart rate. Their main user interface is the camera of your phone and the flashlight. It lights up, and then based on like the pulsation, the tip of your finger, it detects your heart rate. Sleep cycle, one of the other apps. It uses your accelerometer data to see like what your sleeping patterns are. Pretty amazing. These are all apps that no longer require input from your finger. They use input from from sensors. This is fantastic. This is something that was never possible, was not possible 10 years ago. Now, there's one issue with it. And it's boring as hell. It's all so freaking useful. Useful is boring, you know? We're developers. We should not like be copying like other concepts. We need to like start thinking outside of this box. Like this app's, man, it's like 5 years old. Like sleep cycle, we used it 5 years ago to track like how I was sleeping when I'm drunk. Basically goes like, yeah. If I think about like apps that like actually make me excited these days, is none of this useful stuff. No. There's an app, and it's called Send Me to Heaven, which basically done there, been there, done that. You know, the whole mobile revolution is 7 years old. Try something crazy, try something new. Like this is stuff that I actually get excited about. You know, this is stuff that you should aim for when you're building some new stuff. Like all the useful stuff. Done there, been there, done that, you know? The whole mobile revolution is 7 years old. Try something crazy, try something new. So what we're going to do today is not look at any of these useful examples, but indeed we're going to look at some of the sensors that are in your mobile phone today, and you're going to do things a little bit differently. And all of these are going to be examples that you can execute in JavaScript today, in your normal mobile phone web browser. I did this talk, or at least I did a workshop on this some time ago in Hungary, and some guys really amazed me because I told them like some of the examples I did, and this is what they came up with: a weight scale made out of a phone using JavaScript. What they used was you could position the phone on some soft surface, then it balances the gyroscope, calibrates it, then when you put some weight on the other side, you can calibrate it like, okay, if I do 100 grams, I'm going to do that. And then you can just put some points, and it just actually tells you how much that weighs. A freaking weight scale in JavaScript on a phone, come on, you know? Yeah. Sorry, sometimes I also get a bit too overexcited. The device light sensor. The device light sensor is being used mostly, and to be honest, I was writing a book on Firefox OS and sensors at some point. And it's very hard to come up with examples for sensors. Because the device light sensor is just being put in your phone, so it can adjust the brightness of the screen whenever like a lot of sun comes in or there's no sun at all. But then I was looking at an episode of The Big Bang Theory. And in this episode, Sheldon is playing with a theremin. And a theremin is a device that emits waves, and by interacting with the waves with your hand, you can manipulate the sound. Then I figured, if I have a whole bunch of phones that all catch the device light, and I wave my hands in front of it, I can block some of the light out. So when I feed the value of the sensors into an algorithm that generates music, we can generate music by waving our hands in front of our phones. So you can do it now pretty easily because we have the web audio API. And in web audio, there is an oscillator. And the oscillator basically just emits one tone with a certain frequency. If we adjust the frequency by the data, see, this is what I think about. Like, do crazy shit with your sensor, with your mobile phones. Move your hand in front, it will go down a bit, because you're blocking some of the light. Do this with enough phones, and you can create a full-on freaking orchestra. See, this is what I think about. Like, do crazy shit with your sensor, with your mobile phones. So don't think that this is just all theory, and I'm not actually going to do this. I'm going to do this like after I've done all the examples I'm going to show you. Another one, the gyroscope. One of the real purposes that you can use it is to rotate the screen when you flip your phone. But it's quite boring because there's like so much sensors being packed into the gyroscope. You can measure like a lot of forces on 3 axes. And they figured like why not use your mobile phone as like a remote control in real life? A bit like a Wiimote. You hold your phone, you track the sensor data, like how much is the person twisting it or how much is rotating it, and then transform that over a WebSocket directly to your computer. So for example, these are like two phones that I render in 3GS or WebGL, and when I actually move the phone in the physical world, I can now, over the socket, change some stuff on the computer. Now, this is incredibly easy with a library like 3GS. I mean, it's a rectangle with some depth. You can just set it up, you create some materials, create basically a box with a front and a back and some solid color. And then, after we set this up, we can get the data from the device orientation API, which gives you the gyroscope data, and directly feed that into the model in 3GS. And now we have a little Wiimote-like thing made out of your mobile phone, interacting with stuff in real life. Something completely new are Bluetooth beacons. I have some here. Bluetooth beacons are incredibly tiny. The chip inside this beacon is pretty big, it's something like this. $3 if you buy 10,000 of them. And they run for like 2 or 3 years. So you can just stick them somewhere, and then for the next 2 or 3 years it will just tell like, I'm here, I'm here, I'm here, I'm here. This is my ID. Now, shop owners love this kind of stuff. Because you can put a bunch of beacons in your shop, and then whenever someone walks past by, oh no, don't leave us. If you buy this new jeans now, get 10% off. You know, do customer retention. One of the examples that I do is like you put a beacon on all your products, and then at the end of the day you can like see which item consumers interacted with the most. Crap, we have enough advertisement already. Like how the CEO of, I don't know who said it, but it's like we have the smartest minds in the world, all working on like ways of like showing more ads to people. About this shit. We need to actually have some cool stuff. So why not use the beacons as a conference tool? Hey, my phone will know, oh, you can spend 10 minutes talking to this person, like, oh, like reconnect. Or, this is going to be like completely futuristic. What if I have a Google Glass on? Or like a JavaScript powered Google Glass, of course, but it's still a JavaScript conference. I have it on, and whenever I walk up to someone, my phone, running a simple JavaScript API, will just detect that I'm reaching someone, and then will show me some information about the person. Hey, you're starting to talk to Jongboom. He works at the town. This is like the last stuff he did. Or to like take it a bit to the more extreme, use it as like a real life Tinder. Like why not if you're standing in a bar and your phone will say like, hey, there's like 4 single men like 5 meters on your right. Use it as like a real life Tinder. Like why not if you're standing in a bar and your phone will say like, hey, there's like 4 single men like 5 meters on your right. At the moment, there's no support for this in your browser yet, but it's coming. I guess 1 or 2 months. Here is my ID. You get that data, you can consume it. And for example, send it over a socket to your web browser and do some stuff with that. 4th thing, accelerometer. An accelerometer measures the force and consume it. And for example, send it over a socket to your web browser and do some stuff with that. 4th thing, accelerometer. An accelerometer measures the forces being applied on the sensor. So if I'm holding it still, there's no forces here, there's no forces like this, but there's 9.8 force down. It's gravity. I'm just holding it down. 9.8 is stable. When I drop it, gravity pulls it, so for a little while it's 0, and then it bounces on the floor and gets spit up. And people use this, for example, to turn to mute. Because when I'm holding it like this, it's 9.8, and when I flip it over, it's going to be minus 9.8. The other way around. This way you can easily detect like someone forget the phone. And I figured if it can detect the force being applied to it on the z-axis, why not using it as a juggling visualizer? Juggling and throwing stuff up in the air, so I can measure the z forces, the z forces. And when I throw it up, it's going to be quite high for a bit, adding extra force, and then it falls down to 0, and then I catch it. So when I do that with like multiple devices, it should be easily tracking like how much device we have in the air, which one is on top at which point. We can use the device motion API, simple JavaScript API, together with a graph drawing library to see the values over time, get the z data, and just plot it on the graph based on the z-axis against time. You do that. Now you might think, Jan, you've been talking like about like Internet of Things and stuff, but this is like all very constrained to your mobile phone. Maybe you don't want to throw a mobile phone in here. Got something for you here. Some water. If you look at the architecture of a Firefox OS phone, the Firefox OS phone is a mobile phone running on the Mozilla operating system. And it looks like this. First we have mobile phone. On top of that we have a Linux kernel. On top of that we have Gecko, the render engine from Mozilla. So it's essentially a web browser running on kernel. And on top of that there's an HTML5 UI. So everything you see on the phone needs to be rendered by HTML5. Every function you call has to be available in Gecko. Enabling Wi-Fi, there's an API for that. You know, playing around with Bluetooth, there's an API for that. Sending a text to a mobile phone, running a web browser with a whole bunch of JavaScript APIs to do like phone things. Enabling Wi-Fi, there's an API for that. You know, playing around with Bluetooth, there's an API for that. Sending a text message, there's already an API for that. Normally, you cannot access that because security levels. If you strip off the whole UI, you start programming yourself, you have pretty kick-ass development environment. Then the only problem is that it's like still in a phone box. Who cares about that? Now what you can do with these mobile phones is acquire a screwdriver, get the outer casing out of it, and then you get presented with something like this. This is a real phone mainboard. And it's about this size. So let's say we now have this phone mainboard. It's actually this banana for scale. Now we're stuck with not a phone running Gecko with all the APIs. So we still need a way to program that, to run it. So for that I did something new, it's called YonOS. You need to flash it on top of your mobile phone. And after you've done that, you can unscrew it, get the device out of its case, and then you have a super nice, tiny JavaScript board that you can completely program full on with like all the sensors that are in your mobile phone. It's an alternative to Firefox OS, it's like forked. It runs on a variety of phones. You got like community work done on like working on the Nexus 4, the Galaxy S2, so JavaScript boards that you can completely program full on with like all the sensors that are in your mobile phone. It's an alternative to Firefox OS, it's like forked. It runs on a I can buy a full phone in India, including a GSM chipset and some sensors for $30. But if I want to add a GSM shield to my Raspberry Pi, it's $90. That like get me thinking. So get like a cheap phone. Because I can buy a full phone in India, including a GSM chipset and some sensors for $30. But if I want to add a GSM shield to my Raspberry Pi, it's $90. That like get me thinking. So get like a cheap phone, flash it up. And all it is that it runs without a display. This is like actually what you're building with. For example, one of the APIs, I'm not going to talk a lot about this, there's some connecting the phone to this network, so I'm registered with the network, then I can send a text message to a certain number with some text, and then get notified of this. This is some kind of update in the voice network. today, or you see one of the demos today, and you're like, fuck, that's so cool. But I need, then I can send a text message to a certain number or some text, and they get notified of this. This is something you get for free when you start hacking this. So if you see one of the APIs today, or you see one of the demos today, you're like, fuck, that's so cool. But I need to have it like in a non-phone way. Jan, this is your help. So, now the moment that you guys all been waiting for, demos. Alright, so what I have here in front of me are 3 mobile phones, all running Firefox OS, but don't let that scare you. These demos also work in Android. And all of these phones are connected to the same Wi-Fi network, and that is my hotspot. So I need to connect here too, so if someone loses the stream, that is my fault. And the idea is that on my computer runs a simple WebSocket server that just gets the data from the sensors from these phones and then gets them in a web page and then uses that to visualize things. So, make some space here. Alright. Where's my volume table? Okay, if this is going to be really annoying, you can kick my ass later. Alright, so I talked about the Terramin, right? So let me show you that it's actually possible to get data from a light sensor and then generate tones. Beautiful. No, life is so much easier when I was just doing normal demos and nothing with hardware. Now we get some points. Okay, now I really put it out, so now no one is streaming anymore. Here we go. Okay, so as you can hear, there's a tones where I'm going to make it a bit softer. Okay, now what if I like wave my hand from it? Or when I use the flashlight to manipulate this thing, it makes it a bit more light. This is only one phone. We need like an array of phones. This is not cool. Okay, so now I have 2 more of these devices. So they all emit up on a different level. Alright, so that was the first demo. Crazy stuff. Okay, so now let's see if we can use these phones connected as like a way of controlling something on screen, like in the same way as a Wiimote. So if I go to my editor, so what you see here is that I have a number of cubes on screen. These are the 3GS cubes, and I render mobile phones with them. And I use the beta and the gamma sensor from these phones to control them on my computer. So when I open, so now we have one of the phones here. Now you can see that if I move it, it also directly shows on screen. Or if I flip it around, it goes like that as well. Now the fun thing is, as you can see, my desk is not really stable, and it also like flips it forward, so it works. But also I can do this with multiple phones. I have two. So if I now move them like together, so you can use this stuff to actually like play around with like real stuff on screen and do that. Like use your phone as like a real remote control. Cool. Okay. Now we're gonna need the arena on stage. So what I have here is this is data that I get from the beacons that I have, and I have 1, 2 here. Now we can use this data to like see who's close to the computer and like respond to that. So I'm going to give you this one. Okay, stand here. So now whenever someone is close, they should be able the computer should be able to see it, and then uses that data to like give me some information about this person. You see everyone is like about 2 meters away. Wait, okay. Now I'm standing in front of the computer. Ta-da! And now you can walk to the computer and like see that it actually works with like multiple beacons and multiple people and like standing close.
Wow.
Ta-da!
Maybe you mistranslated.
I Google Translate for it. Alright, so that was beacon stuff. This is stuff you can already do. Your Mac supports this. Now, the last thing that I want to show you in terms of demos. Not Jongboom visualize. Right, so I have a phone. This is the cheap one, so I can drop it. When I click this button, we get like the data from the accelerometer, like plotted here. As you can see, it's like pretty stable, around 9. And when I do this, you see that like actually stuff happens. Now, for me the cool part is like if you drop it, you can actually see that's like zero force at some point. Safety mechanism. You can go upstairs. Thank you. So if I drop it, you can see that actually for a little while there's zero gravity on the thing, or zero force. Now this is super useful when juggling, because look at what happens if I start like moving it like up and in, or throw it in the air. There's like a clear pattern emerging. A very clear pattern, where you see that at some point you throw it up, and then it's for a while it's like zero. Now of course that's only with one phone. One phone is not so cool. But if we do it with 2 phones at the same time, so if you do it with 2 phones at the same time, you see that it's pretty easy to distinguish which one is on top at which point, right? So if I now actually start juggling with this, Should be pretty easy to see. Actually, the first time I did it was practicing on a bed in Bangladesh, standing. Please don't go there. No one saw that. No one saw that. All right, so there you have it, a real juggling visualizer. If there's someone who can do this with like 3 devices, then please come on stage and do this, because I never learned that. Now, what I told you was that you can not only use like your mobile phone to do this. You know, you can break your phone and then use like a little chipboard inside to do this work for you. Let's say you want to build this into a real juggling ball. So this is how one of those boards looks like. It's really tiny. Unfortunately for Wi-Fi, you need like a battery to connect this. I don't have solar, but I have a little device here. I just need to verify that it's actually on, because otherwise I'm going to be very stupid. Okay, so it's on. This is a device made from a mobile phone. It is essentially the little phone board that I just had here, together with a battery, just soldered. Pretty big battery. Because I wanted to, you know, I want to experiment with this. Just 3D printed case. Now, let me show you that this actually works the same way. If I go to the Firefox developer tools, because that's what you can still use to debug these devices. I see that I'm connected to Wi-Fi. Wi-Fi is on, and I can start like the journey. This is the same thing we run on mobile phones. And what you now see is that I get this data from this device instead of mobile phone, and when I throw it up in the air, it still works. So this stuff just doesn't work in a mobile phone, it actually works. We break the mobile phone, install the operating system on it, solder a battery into it, wrap it into a 3D printed case, and even then you can visualize your code. So, that's pretty fucking amazing. So, to conclude, this is how I felt, you know? So, to conclude, if you want to start hacking on this stuff, all these demos are open source, they're ready, they're here today. You know, grab a phone that has the latest Chrome or Firefox, they all support these APIs that we saw today being used, and start just consuming that sensor data. You know, start like thinking outside of the box. For me, working with these sensors, working with Internet of Things, working with connected devices, gave me the same freaking like excitement as when I first started programming. Like the first time you wrote like an application, you just said, "What's your name?" Oh, hallelujah. You know, that is the stuff that you get like once in a lifetime. The first time that you actually make a computer do what you want it to do. And for me, using sensors, using Internet of Things combined with JavaScript gives me like the same freaking excitement. I want to run to my mom and like, "Mom, look, I can juggle with my phones and show it on a computer." That's the stuff that I've been looking for like a long time, and I very much hope that everyone gets that excitement back the moment you start playing this. And with that, I want to thank you all for being here.